In the meantime, let's take a look at the sky. We're going to jump right to Stellarium tonight. And when I do these things, I like to have try to make them fresh each month we do this, just to make them a little different. So my theme tonight, for the most part, maybe a few exceptions here and there, are going to be constellations and deep sky objects that are either named after animals or are of animals. And it's going to be kind of all about animals today with a few people thrown in for good measure. After all, I mean, up in the woods in Rangeley, there are lots of critters. So we're going to take a look at some of the critters in the sky. We're going to jump right in about 9:15 tonight. We've got the sun down below, and it's just at the point where the sky is really starting to get dark. And if you've done this with me before, I often like to start with something you're already familiar with. And the one thing most people are familiar with, if they don't know anything else in the sky, is the Big Dipper. And if you look right here in the northwest, about halfway up in the sky, you're going to see the familiar 7 stars of the Big Dipper. Starts here, curves around, and comes down with a little square for the pot. Now, you might say, what does that have to do with animals? Well, technically, the Big Dipper is not a constellation. It's part of a constellation known as Ursa Major, which means the Great Bear. So let's turn the Big Dipper into a bear. Oh, let me click the right star here. There we go. So doesn't that look like a bear? Well, not quite, perhaps, but that's the way the bear is drawn in the sky. The handle becomes the bear's long tail, because you all know bears have long tails. And then we get the body here with the nose out in front and a couple of front legs here and a couple of back legs there. I know it's a very strange looking bear. There are lots of stories about the bear that explain the bear's long tail and why he's a skinny bear versus a fat bear. If you have a hard time seeing that, we can also draw the fancy picture like this, which kind of, rounds him out a little bit. When I was a kid, my mom bought me a book on stars, and the only pictures were pictures like this one. And I took it out in the yard and tried to find constellations. And I'll tell you, I couldn't find anything because I couldn't see that bear in the stars at all. I didn't know how they came up with that. It wasn't until years later that I got a book that showed, dot to dot drawing pictures in the sky. I mean, the artful ones are nice to look at, but it's not easy to see that in the sky. So, oops, I just pressed the wrong button. Let's get rid of that picture and imagine that as the Great Bear. Now, the Great Bear has a companion right beside it. When we think of the Big Dipper, we often also think of the Little Dipper. Well, the Little Dipper is Ursa Minor, which means the little bear. To find that little bear, find the Big Dipper first, which is technically part of the Big Bear. Go to the back 2 stars of the pot. They're called the pointer stars. Draw a line up through them, and they'll point you to the first reasonably bright star you come to is the North Star, Polaris, probably the most famous star in the sky, not the brightest star in the sky. There are at least 47, 48 stars brighter, way down the list of bright stars. It's famous because it's the only star directly above the Earth's North Pole. So if you're standing at the North Pole to see it, you'd have to look straight up. Well, in Rangeley, you're not at the North Pole, and Rangeley is a much nicer place to be. So the height of the North Star is equal to your latitude. Draw a line from the North Star to the nearest spot on the horizon. It'll be almost within a half degree of true north, more accurate than your compass. And if you measure that angle from the North Star to the horizon in degrees, it'll equal your latitude. Now, I know the latitude of Rangeley happens to be 45 degrees. There's that sign right in town. You've all seen it. And if you measure that angle from Rangeley, it would be 45 degrees as well. So that's a way of navigating. Well, it also marks the end of the Little Dipper, which is the Little Bear. And there's no difference between the Little Bear and the Little Dipper. So you just have to envision that as a little bear with a long tail too. Both bears have long tails. You have to bend your imagination a little bit to see these things. Now, there are some things you might want to search for if you had a telescope in these bears. And since we're going to limit ourselves to, I keep hitting that button. That's a coordinate system, which I don't really want to use today. So let's just look at the Big Bear. When you find the Big Bear and you find that Big Dipper, go to the backside of the pot, go right underneath it, and right about in here, let's see how close I actually am, you're going to find our first deep sky object of the day. And I'm not on it, but I'm very close to it. It's this little object right here. It's called the Owl Nebula, sticking with our animal theme here. And you can kind of see why it's got the name the owl. Doesn't it kind of look like the face of an owl, a round face with the two big eyes right there? What we're actually looking at with the Owl Nebula is called a planetary nebula. They have nothing to do with planets. In the 18th century, right after the planet Uranus was discovered, everyone wanted to discover their own planet. So they were searching their sky with their telescopes. And they found these round objects. And they thought maybe that's a planet, or maybe it's something that's forming into a planet. And they knew they weren't planets because they weren't moving, and all planets do move against the stars. But they thought maybe it's some sort of planetary region or something. We now know that it's really kind of the opposite. This is a star that has died. When stars like our sun run out of fuel, they're burning hydrogen into helium, and then as they get older, they turn helium into carbon, and then they can't go much further, so they start to shrink. And when they shrink, those fusion reactions don't happen in the core anymore. They happen about halfway out from the core to the outer edge of the star. And when that reaction happens that far out, it pushes the outer layers of the star away. And those layers go floating off into space, and they make a spherical shape of gas floating away, otherwise known as a planetary nebula. And that's what we're looking at here. When our sun dies, it's going to create one of these. I mean, it's not a giant explosion like a supernova. This is not a star blowing itself to bits. It's just pushing the outer layers away. Now, if you happen to be on the Earth, it would ruin your whole day. It would destroy the planet and all that. So it's pretty devastating for anyone living on the Earth at that point. But don't lose sleep. It's not going to happen for at least 5 billion years. But that's an example. And this is the Owl Nebula, right under the pot of the Big Dipper or under the belly of the Great Bear. So we've got two animals so far. We've got Ursa Major and Ursa Minor, the two bears. If you want to find a mythical animal, look between the two, and you find any stars you see here. See this line of stars right through here? That's the tail of Draco the dragon. He winds up between the dippers like this and spins around, and there's this little, let's back off a little bit, a little circle of stars marking his head. So that's the dragon. So we have real creatures like bears and mythical creatures like dragons in the sky. And you can always find the dragon by looking between the two dippers, and any stars you find there are pretty much going to be part of the dragon. It goes out between the dippers and winds along the upper side of the little dipper, then bends back around like a big S, and backwards S that is, and with a little square or circular group of stars for a head. So there are three creatures in the sky. Now go back to the Big Dipper again, something we can all find, right? You see how the handle of the Big Dipper arcs or curves? If you follow that curve around, it points you to a very bright star, a star named Arcturus, which is the brightest star in the Northern Hemisphere. There are brighter stars south of the equator, but for us in the Northern Hemisphere, north of the celestial equator, which is this line right here, that will be the brightest star you can see. Now, we can see stars in the Southern Hemisphere, but that's our brightest. And it's in a constellation, not of an animal, but, well, sort of an animal. It's a picture of a man. He is Boetes the bear chaser. Well, we've got the great bear here and the dragon. He doesn't care about the dragon, but he is chasing that bear because he's a herdsman and he's trying to chase the bear away from his herd. Well, the herd's not shown in the sky. I think they're left far behind. So to see this herdsman, this bear chaser, as we call him, he's made up of these stars. Doesn't that look like a man chasing a bear? I'm not sure exactly how you see that as a man chasing a bear. I mean, they draw him kind of like this. And I don't know how you get that picture out of those stars. Most people today don't draw Boetes as a man, just like we don't draw the great bear as a bear. We draw it as the Big Dipper. So we draw Boetes, the bear chaser, as an ice cream cone. Arcturus is the point with a side here and a side there, and there's the opening on top. So that's our cone. And this big round circle, and I add a few of these other stars in here because they're actually part of Boetes, and make a nice big scoop of ice cream on top. I think it's heavenly hash, but you can pretend it's any flavor you want. So that's Boetes. Now, he's not chasing the bear alone. He has his two faithful hunting dogs. These two stars under the dipper's handle are the two hunting dogs called Canis Fanatici. And it's just the two stars. So if we make our picture here to keep our theme going, we can see the bear chaser with the two dogs chasing the bear. The little bear's up here running in circles, and the dragon, he's just watching the whole thing because he's kind of make believe anyway, right? Now in Africa, North Africa, you can't see many of these northern constellations, but they do see these three sets of two stars, this two here, these two, and these two. Sometimes they're drawn as the feet of the bear, like we see here. Sometimes the back leg shows this is one back leg, and the other back leg comes down to these two. In North Africa, they refer to these three sets of two as the three leaps of the gazelle. So you can imagine a gazelle is a deer-like animal, and it's leaping, leaving footprints in the sky. There's a pair of footprints here, another here, another here. The three leaps of the gazelle. So I like to imagine not only is that bear chaser and his dogs chasing the bear, but they scared a gazelle away, and all we see left of him are his hoofprints in the stars. Well, so we found some interesting animals up here in the sky, in the western sky tonight, and we found the Owl Nebula. Well, halfway between Arcturus, the point of the ice cream cone, and the southernmost dog, right about in here, we're going to find a cluster of stars. Let's see how close I am on this one. And I am not too far away, I don't believe. Where I've lost it here now. Let me find it. Oh, I'm above it. It's right down here. It looks like, and they've labeled it M3. It has a common name. Its common name is the jellyfish cluster. So here is the jellyfish. Let's zoom in on it. You need a telescope to see this, and it's quite beautiful. This is called the globular cluster. Now, globular clusters are made of really old stars. These stars are older than the sun, so they may be 10 billion years old. And this cluster, the jellyfish cluster, has 500,000 stars in it. It's a huge group of stars. It is about 33,000 light years from us, so it's a long ways away. Globular clusters halo around the galaxy. We live in a galaxy called the Milky Way, and they don't tend to be inside the galaxy. They're kind of floating around it, and there's hundreds of them scattered around the Milky Way. And we see them around other galaxies too. Well, this is one you can find right between Arcturus and the hunting dogs. Scan the sky and you may find it. It's called the jellyfish cluster, and there are 500,000 stars here, and it's quite beautiful. And when you look at it, sometimes, depending on you, if it's a small scope, it's going to look like a fuzzy star that someone tried to erase with a bad eraser. A bigger one starts showing you individual stars like you see here. It might look like a little pile of sugar or salt, or maybe if your telescope's big enough and you resolve the stars fine enough, it looks like a little pile of diamonds. I'm not sure why it got named the jellyfish. I don't see much jellyfish. I don't see any tentacles or anything coming down, but it's going to be named something, I guess, right? So there's the jellyfish, globular cluster of stars. There are different kinds of clusters. The globular clusters are made of old stars. In a few minutes, we're going to see another type of cluster made of young stars. Now, so far, we've stick pretty strongly with the animal theme, but I'm going to leave it just for a moment because there's something in the news that you may have heard of. Have you heard perhaps about the star that they're talking about that's going to explode? Well, it's not actually going to blow itself to bits. It's going to burn off fuel on the outer layers, and it's going to shine very brightly for a month or so. And it's called the Blaze Star. You might also see it called T Corbor or T Corona Borealis. And I want to show you where that is. It's not in an animal-themed constellation, which I'm kind of bummed about right now. But you see that ice cream cone? Right behind it, you might notice this little half circle. That is Corona Borealis, which means the northern crown. We don't see many animals other than humans wearing crowns, but you might think of it like a tiara like a princess would wear. The brightest star's name is Gemma. Appropriate name for a crown. Crowns have lots of gems in them, so the brightest one is Gemma. Well, this crown's going to have another bright star sometime in the next several months. It could happen tonight, might be tomorrow night, might not be till Thanksgiving, but it's going to happen soon. And it's going to appear right about here where I've got my arrow. It'll be brighter than Gemma, not as bright as Arcturus, but about the same brightness as the North Star, which we saw a couple moments ago. With before it flares up, you cannot see it. It's too dim to be seen with our eyes. With a big telescope, you can see it. It looks like a faint star. What we know is happening here is it's not really one star, it's a binary star, which means there are two stars there. And that's not uncommon. What makes this one special is one star is a red giant, meaning it's absolutely huge. And the other one is a white dwarf, which means it's no bigger than the Earth, but much, much denser with lots of gravity. And they're going around each other. The little one's more going around the big one. And the big one's swelling up so big because it's old and getting ready to die, and it will blow perhaps one day. But it's swelled up so big that the gravity of the little one is pulling gas off the big one, and it pulls it off at a regular rate. And it builds up on the surface of this white dwarf, and it builds up and builds up. And after about 80 years, there's enough weight that it squeezes the lower levels of that hydrogen, and all this gas is hydrogen, that it starts nuclear fusion. And all the fuel burns off in about a month. Sometimes some suggest maybe 2 weeks, and it will flare up, and it's called a nova, not a supernova. Supernova is a star that blows itself to bits. A nova can happen over and over again. This one happens every 80 years. The last time it happened was in 1946. Before that, it was in the 1860s, I believe. And it's been seen several times. Now, the reason we know it's about ready to happen is because when it's happened in the past, scientists have noticed that it's down at 10th magnitude, which is much fainter than we see with our eyes. But just before it brightens up really bright, it dims a little bit. And apparently it's already done that. It usually dims for a couple months, and then suddenly, kaboom, it flares up and comes up to about third or fourth magnitude, about the same as Polaris, the North Star. And it will stay that way for a couple, 2 or 3 weeks, maybe a month. Then it's going to fade away and disappear for another 80 years. So don't look for a giant explosion. If you didn't know what was happening, and didn't know the stars, you might not notice. It's just going to be like a brand new star in the sky, temporary, right about there. So that's been in the news a lot, and that's where you want to look for it. So find Arc to Arcturus and find Boötes, the ice cream cone, or the bear chaser, Northern Crown, and you'll see Gemma. And when that happens, the crown will have another gem right over here. Well, now let's jump down from the Northern Crown and the ice cream cone down to the southern sky. And when we get down the southern sky, we find another critter. We're going to get back to our animals here. You're going to see a red star. This is a red giant. It's closer than the one in the Blaze star, but kind of the same sort of thing. This one's called Antares, which means the false Mars, because it has about the same color as Mars and a similar brightness to what Mars often has. And people see it and frequently think it's Mars. It's not. It's a red giant star named Antares, which ANT means false, and Aries is the Greek word for Mars, so hence its name. Well, it marks the heart of Scorpius the scorpion. So to see the scorpion, think of Antares as the heart. Come up here, and this is the head. Then you come down past the heart, and the body comes almost all the way down and right along the edge of the horizon. Here in Maine, it's often down in the trees, especially if you're in the North Woods. But then it comes back up, curls around, and there's a bright star at the tip of the tail. Two little stars there, one a little brighter than the other, and that's the stinger, because scorpions have stingers on the end of their tails. And the scorpion has claws, one on each side of the head, one here and one here. This program draws the claws coming from the heart. I usually draw them coming from the head. I have the head here, and I have an arm over here. And I'll come all the way down and use this triangle for a claw. And then I come back to the head and I draw over here and make this triangle the other claw. Now, there's not a right or wrong way to do this. You can draw constellations any way you want, whatever helps you visualize it. Just like we draw the Big Dipper instead of the bear because people can visualize the dipper, or an ice cream cone instead of the man. You see, technically, everything inside that red polygon is part of Scorpius. And you can use the stars any way you want to imagine the picture. In ancient times, they drew the scorpion a little differently than we do today. They made the claws go all the way up to these two stars. Now, they're in a different constellation today. They're in the Libra, the scales, which is not an animal. But the two stars that used to be the tips of the claws have cool names. This one's called Zubin Shmali, and this one's called Zubin Janubi. And Zubin Shmali means the northern claw, and Zubin Janubi means the southern claw, because they originally were the claws of the scorpion. Well, let's just get back to the Scorpion here and find something interesting. Go down to the tail, look just to the left of the tail. And first of all, you can do this with binoculars. Better with a scope, but you can see it with binoculars. You're going to see a little clump of stars right there. It's called Ptolemy's cluster. Now, we're not going to stick on this because Ptolemy's not an animal thing. He was a man that lived over 2,000 years ago, and he wrote about this cluster because you can actually see it with your eyes. It looks like a little fuzzy little patch of stars in the sky. Once you find, and it's very pretty, especially with binoculars, it looks like a little pile of diamonds. These are the young stars I was talking about. The globular cluster we saw, remember the jellyfish, had 500,000 stars. Ptolemy's cluster may have a couple hundred stars, and they're young. These stars are about 200 million years old. I know that sounds old. For stars, that's kind of like being in middle school. You know, they're in 7th grade and they're hanging out just like 7th graders do. Where I want you to look is once you find that, look up and to the right. Maybe think of it with binoculars, move towards 1 o'clock, and you're going to find a smaller cluster of stars. This one's called the butterfly cluster. It's the same thing. It's another young group of stars. This group is a little bit younger. It's only 94 million years old. So these are maybe 5th graders instead of 7th or 8th graders. They're a little bit younger, but they form the same way. They look smaller because they're twice as far away. The butterfly cluster is 1,600 light years away, while Ptolemy's cluster is only 800. You can see them both with binoculars. They're nice sights. You see these little clusters. This one got called the butterfly cluster because people envision the butterfly's body here, then a loop for wings on one side and a loop of stars on the other. And then kind of see a butterfly there. You can see these two little V shapes here. Imagine those as the wings and the body in the middle, perhaps. Takes a little imagination. I think astronomers spend a lot of time looking at these things and trying to make some sense of them, to name them something that means something. So this is the butterfly cluster, and there's about 125 to 300 stars. It's about 100 stars that are nice and bright. And then with the larger telescopes, you can see fainter stars, which brings the count up to about 300 altogether. You won't see 300 with your binoculars. You'll see maybe 80 to 100. So there's the butterfly cluster, along with Ptolemy's cluster, right behind and above the tail of Scorpius the Scorpion. Now, once you're there with your binoculars, or better yet, your telescope, go right above it, just scan up through here, and you're scanning through the Milky Way. If we back off, you can see the Milky Way here. And when you're in Rangeley, the sky is going to look a little different than this because I have it set for the way the sky would look here in Greater Waterville, where I live, and out in the countryside, of course, not right in town. Rangeley, you have darker skies than we have here in central Maine, and in Rangeley, the sky is going to look more like this. Many more stars, and the Milky Way is much, much brighter. You can see it right here. So come back down to the tail of the Scorpion. If we turn the Scorpion back on, you can see it right there. And you see Ptolemy's cluster. And if you look carefully, you just see the butterfly cluster there. Zoom in on it. Well, if you scan through this Milky Way, you're going to find lots of little clusters scattered all over the place. I'm not going to go over them all because I'm going to try to stick to things that relate to living creatures. The first thing you're going to notice, though, other than clusters, is this little patch of light here. And here it looks pink or red. It is pink and red, but if you look at it with a telescope or with your binoculars, you will not see any color. This is a nebula. This one's called the Lagoon Nebula. Now, that's not a living creature, but it might be a place where creatures live, right? Things live in lagoons, and that's what this one is called. These red nebulas are giant clouds of hydrogen gas, and you see a cluster underneath it here and another little nebula above it. And they're all kind of the nebulas are all kind of the same thing here. Not the same as the butterfly, as the Owl Nebula. That was a star that died. These red ones are where stars are forming. This is a huge cloud of hydrogen, which is what stars are made of. This nebula is 100 light years across this way and 80 this way. It's huge, and it's shrinking and forming young stars in the center. And you see some young stars here. So the Milky Way is filled with these. And I want to show you a couple more, a couple that relate to our animal theme. So we're going to move away from the lagoon and just start scanning above with your binoculars or your telescope. And as you do, you're going to pass a whole bunch of these open clusters of young stars. When they look irregular and loose like that, they're open clusters. There are only two types of star clusters: open clusters, young stars, and globular clusters, which are old stars. Scan above, you can see a really large one here. It's called the Sagittarius star cloud. But right above it, you're going to see a little nebula right here. This is another one of those clouds that, excuse me, where stars are being made. This one is known as the Omega Nebula, or more commonly called the Swan Nebula. So look at this and see if you can see a swan there. Again, it's all hydrogen gas forming stars. And these bright stars you see amidst it are young stars. These stars may only be a few million years old, not even 50 or 100 million years old, maybe 5 or 10 million years old. They're young stars. And the way I see the swan, I've looked at it, I always try to figure out where these names come from. To me, this is the swan swimming. This is the swan's wing here, and the body is right in through here. And then you see the neck bending up around, and this is the head, and you kind of see the bill right there of the swan. But then again, maybe I've been doing this for too long or something. I don't know. Some people have a hard time seeing that. Some people make a larger swan, but it's called that. Now, with your eyes, again, remember, you're not going to see the red color. The part of our eyes that sees faint light is colorblind. You'll see all the details. You could see the shape of this swan. If you can see it here, you can see it through your telescope or binoculars, perhaps, but it's going to look like it's grayscale or black and white. If you put up your cell phone to your telescope and take a picture, it'll look red. It really is red. Our eyes can't see it. The red color comes from those young stars, which give off lots of ultraviolet light, excite the hydrogen gas. And when the gas gets excited, it starts to glow. And when it glows with a red light. And there we have the Swan Nebula. Well, let's go just a little bit further above the Swan Nebula. Let's back off here a little bit. You go right above it, and you're going to find another one of these nebulas. See, the Milky Way is filled with these star-forming regions. And this is one you've probably seen pictures of before. It's called the Eagle Nebula. Now, when I first started looking at this was always one of my favorites. And as I analyzed it and tried to find the eagle that it's named after, I always saw this little feature in here, this dark nebulosity. And I pictured this as the eagle's body with a wing here, like it's flying, and it's holding a fish in its talons, the way you often see an osprey flying with a fish in its talons. And I could envision that. And I showed that to a friend, and he said, "No, that's not how you see the eagle. The whole thing's the eagle. This is the head up here on top with the wing out on one side here, and the other wing stretched out over here." So whatever way works for you. But it's the same thing. It is a cloud of hydrogen gas, and it's a place where young stars are being born. Now, I said you may have seen this in a very different form. When the Hubble telescope first went up, they pointed at this object, and they took this very famous picture that hopefully some of you have seen called the Pillars of Creation. And you think about what that picture looked like. This thing I drew as the eagle are the pillars of creation. Those are places where stars are being born. Someday this will be gone and there'll be stars in place of these things. And these don't look very big, but this one right here is absolutely huge. 20 from here to here, 20 trillion miles. Not a million, not a billion, but a trillion, not just 1 trillion, 20 trillion. Now, I find most people don't understand really the difference between a million and a billion and a trillion. Yeah, everyone knows a billion's more than a million and a trillion's more than a billion. But how much more? Here's something to consider when you think about 20 trillion miles. Think about these numbers in terms of seconds. A million seconds is 11 and a half days, something that most of us can grasp, 11 and a half days, a little over a week. A billion seconds is 31 and a half years. For elementary kids, that means that's like an old person, right? 31 and a half years, that's a billion seconds. A trillion seconds is 31,500 years. So think a trillion is a huge number, much more than a billion, and way, way more than a million. And then when you look at this and realize it's 20 trillion miles long, we're looking at something very, very big here. And very beautiful, too. Something interesting to ponder. Another animal feature in the sky. So there is our Eagle Nebula, all hidden in the Milky Way, right above the constellation of Scorpius the Scorpion. And this funny looking thing is Sagittarius, which was a creature that had the body of a horse, and where the neck would come up was the upper body of a man. I'm not sure how you make those things look that way. They draw it something like this. I think that stretches the imagination. Most people I know don't draw Sagittarius as a centaur, because trying to envision that picture out of those stars is challenging. Instead, we draw Sagittarius just like we draw the big bear into a cooking pot. We draw Sagittarius as a teapot. And it makes a pretty nice little teapot. There's the base and a spout on one side, a handle on the other, and a lid on top. So you can pour the tea right here. And the Milky Way might be the steam coming out of the teapot. Just a fun way to be able to find Sagittarius in the sky. And remember that the first nebula, the Lagoon Nebula, is right above the teapot spout and right above the tail of the Scorpion, which is these two stars over here. We pull back just a little bit. So we found a few cool animal things in the sky. Let's find a couple more. Let's go a little bit higher in the sky. We're going to back off and kind of look almost straight overhead tonight. And when we do that, we're going to see a really big triangle in the sky. Now, I'm going to put a little bit of light pollution here for us for a minute. If I had the choice to be outdoors with light pollution or not, I would always choose not. But to teach you on here, I think it's easier to see the constellations with fewer stars. So let's just add a little bit of atmosphere back in here. And now those three stars really hop out. That's Deneb, Vega, and Altair. That's called the summer triangle. It's not a constellation. It's just three bright stars that show up in the summer every year, and they're visible throughout the summer and throughout the fall. And two of them relate to animals. Let's start at Altair. Altair is an aquila the eagle. Now, I'm not going to show you initially the way they draw, because I don't like the way they draw. Remember I said you can draw these any way you want? Well, the way I draw this is start with this. Well, you can start with this star over here. And I envision this eagle is not as flying the way you see it drawn in most books. I see this eagle as sitting on the branch of a tree. Maybe you've seen an eagle sitting in a pine tree looking around. Well, envision it that way. Start with this star right here. Draw a line up to this star, then to this one, then this one. And that's the branch he's sitting on. The two middle stars, this one and that one, are his two claws grabbing the branch. So he's got a foot there and a foot there. This oval circle is the eagle's body with his tail dipping below the branch. Come up to the top two stars, those are his shoulders, and draw a line past Altair to this star and come down. You get a nice triangle-shaped head. You could pretend to color it white for a bald eagle if you like. Don't look for any wings. He's perched, and they fold their wings in. So just see the branch, the eagle sitting on the branch with the white head, and Altair, the brightest star, is his beak. And he's looking off to the east over here, or to the left. And we'll take a look at what he's looking at in a moment. So that's the way I draw the eagle, and I can look at that and envision it. Now, remember, technically, everything inside this boundary right here is part of Aquila the eagle. Now, I use one star that technically is not part of the eagle. That's this star right here. But to help me visualize it, I bend the rules and do that. And you can do it or not. It's your choice. Now, the way they draw this eagle is a little different than the way I do it. They draw it like this, and I don't think that looks like a very good eagle to me. I've yet to see an eagle with a flat face, and you get the wings and the tail here. If you have a telescope, go down to the bottom of the eagle, down below, and you can see this nice little arch right here. And right in here is another open cluster. I'm going to shut the lines off so we don't have to look at the lines. And it's called the wild duck cluster. And it's right, I was pretty close, right here. It's an open cluster, which means it's young stars as opposed to old stars. I'm not sure if it's supposed to look like a flock of ducks or a single duck. This picture doesn't do it justice. When you look at this with the scope, it's a really beautiful little group of stars. They're about 5,460 light years away. So remember, a light year is not a length of time. It's a distance. It's the distance a beam of light will travel in a year's time. And light travels at 186,000 miles per second. So if you go in a straight line at that speed for 1 year, you're going to cover a lot of miles. That would be 1 light year. This object is 5,460 light years away. Now, that means, though, there is an element of time here, because that means when the light leaves the stars in the wild duck cluster and heads for your eyes, when it leaves the stars, it'll take 5,460 years to get to your eyes. So when you look at this, you're not seeing it the way it looks today. You're seeing it the way it looked over 5,000 years ago. It's kind of interesting. And the farther something away is, the longer back in time you're seeing it from, because it took that much time, however many light years away it is, for the light to travel from that object to your eyes. So this one's the wild duck cluster. These stars are about 250 million years old, a little bit older than the stars in the butterfly cluster, but another open cluster of relatively young stars. These ones might be in high school if we keep our analogy going. And it's right down by the tail of Aquila the eagle. Let's bring our eagle back up here. It's actually in this constellation, which is Scutum the shield, but that doesn't do with animals, and you don't need to know Scutum. It doesn't look like a shield to me. But you can find that eagle perhaps and go right down below his tail and find this nice little curve of stars, and it's at the western side right there. Just scan around. When you find that little clump of stars, you'll know it when you see it. It's quite pretty. The wild duck cluster. So let's keep going. Let's look back at that eagle. He's sitting here. There's his body, and Altair is his beak. And he's looking off to the left at a neat little constellation called Delphinus the dolphin. This little diamond shape is the dolphin's body, with a nose on front and a fin on his back. And then the tail comes down like this. We can put some lines on him like that. And it kind of looks like a dolphin jumping out of the water, maybe a dolphin jumping out of the Milky Way, if you will. So we've got the eagle, not the way I see it, but that's the eagle. And he's definitely got his eyes upon that dolphin. Well, nice little nature scene going on here. Go right above it to the next star in the summer triangle, Deneb, and that's the tail of Cygnus the swan. Deneb is an old Arabic word which means tail, so it's appropriate that it's the swan's tail. To see the swan, think of this as the tail. Star Satyr is the shoulder, so you could draw a line for the body, but swans, as we saw with the Swan Nebula, are big birds. So I always draw an oval between these stars. Give that bird a little heft. So here's his tail, here's his shoulder. Now this one's flying. In the nebula, he was swimming in the lake. This one's flying, so let's get some wings on him here. One wing comes up to this star and up to this one, then back to the tail. Come back up to the shoulders. The other wing comes down to this star and over to this one, then back to the tail. Then come back to the shoulders again, and the swan has a very long neck to Alberio, the head of the swan right here. Put some lines on it. They draw it slightly different than I do. I usually just go to this star, then I come back around to the tail, and I draw the lines back and fill those wings in. But if you want to put the pictures up there, you can envision the swan. And I think the swan really kind of looks like a swan. You can envision that. The eagle, you kind of have to work at. The dolphin, I think, makes a pretty good dolphin. Some constellations are easy to visualize and some are a little more challenging. I'm going to show you one here in a few minutes that's incredibly challenging. But these ones I can kind of visualize myself. And just to keep people in the scene here a little bit, if you look between the eagle and the swan, you see these two stars and then these two. That's Sagitta the arrow. So imagine an arrow. Someone's trying to shoot one of these birds out of the sky, and they clearly miss because it's flying between them. But we see an active scene in the sky. You almost need some music for this nature scene, right? You've got the eagle staring at the dolphin, someone's shooting arrow, and the swan's flying by. We need a soundtrack. So we come up to Vega, the brightest of the three stars. And this is the only one that's not in a living creature sort of thing of the three. It's in Lyra the harp. And the harp I always draw is just this triangle in the stars like this right here, with Vega halfway down one side. Kids always want Vega to be one of the corners, and it's not. It's halfway down the side. And a little boy asked me, well, why do they put it there? Well, no one put it there. It's just the way the stars are and the way we draw the picture. So I always like to pretend that that's where a string broke and it went pring and made a bright star. And that made the little boy happy. So That's my story, and I'm sticking with it. Sometimes it's not drawn as a triangle the way I draw it, because that's the harp most kids know. Sometimes it's drawn as a lyre, which is the type of instrument like Nero played with a lyre. And that's drawn as this parallelogram like this, maybe with a little triangle on top. That's a little bit harder for most kids to visualize, but it is Lyra the harp. So here are our constellations around the summer triangle. We've got the harp playing the music for our soundtrack, the eagle flying towards the dolphin, and the swan flying down the Milky Way with the arrow flying in between. So kind of a neat little scene up there. Go down the bottom of the Milky Way, and we find the scorpion down here, waiting for someone to fall, perhaps. And off to the northwest, we've got the bears and the bear chaser and the hunting dogs. All kinds of interesting storylines going on here in the sky. Follow that Milky Way behind the swan, and we're going to find a few more critters to consider. I'm going to just get rid of the labels here and just bring up the swan to start with, because that's a good one that's easy to find, because it kind of looks like what it's supposed to. And right behind the swan, you might notice a little, no real bright stars, but a little zigzag in the stars right here. See that zigzag? Let's zoom in on it just a little bit. Right above the tail of the swan, you'll see a zigzag. That's Lacerta. They draw it quite differently. I've seen it drawn as a zigzag, and it's supposed to be Lacerta, the lizard. So I always envision this lizard is, they're very sporadic, jumping around, trying to avoid things. So that's the lizard. Right behind the lizard, we find the W of Cassiopeia, the queen. Now, the queen, well, it's supposed to be the queen, and I guess queens are living creatures too. We don't have to all be wild animals, I guess. But here in this, with this queen, there is another open cluster that's very pretty to look at. It's easy to find. Find the W, go to the left-hand side and start it here and come down and just step just below it, right about in here. And you can see another cluster. This cluster is called NGC 457. NGC stands for the New General Catalog, and there are thousands of NGC objects. This one is called NGC 457, but it has a common name. Its common name is the ET cluster. So let's bring it up. It's right here. I'm going to zoom in on it. This ET cluster is 8,000 light years away. This is the most distant one we've seen yet. Turn the stars off so we can just look at the picture. So the stars aren't as bright, but there's a real scattering of stars. It really does look like someone spilt the salt there or something. These are young stars again. It's also known as the dragonfly cluster. So it does have an animal name. But I like the ET cluster because ET is the extraterrestrial. We are talking about space after all. So why not have an extraterrestrial form of life in the sky? And what I like about this cluster, besides all those little faint stars kind of scattered around, is we get that nice orangish red star in the mix. And a number of clusters have occasionally a star of a slightly different color or a little bit brighter like these two here. And it makes each open cluster kind of unique and interesting to look at. Globular clusters have lots of stars and they're quite beautiful, but they all kind of look the same. They're all just this round glob of hundreds of thousands of stars, sometimes a million stars. These are much smaller, only a few hundred stars, but they are less regular in shape and formation. And so you can get to know these and recognize them with just someone showing you a picture and go, oh, that's the ET cluster. Or, oh, that's the butterfly cluster. Once you look at them a few times, you can get so you really identify them by the patterns you see or the colorful stars or the way the bright stars stand against the fainter stars. So this is the ET cluster, 8,000 light years away. Pretty easy to find because it's in Cassiopeia, the W, which is, other than the Big Dipper and Orion in the wintertime, probably the third easiest constellation for most people to find in the sky. And it's right underneath, scan right in here. If you scan around, there's a whole bunch of other few clusters in here too, but this is the one that's kind of right dead ahead of that line right in there, the ET cluster. Kind of a fun one to check out. Well, there are a couple other constellations here that relate to animals. Go down and underneath and over in the eastern sky, you're going to notice a great big square standing on a point on one corner. You see that square right there? It's called the Great Square of Pegasus. If you know your mythology, Pegasus was a horse, a flying horse. So we got a little bit of the fantasy going on here, but a horse nevertheless. And so I want you to look at that, see if you can envision a horse. Let me take the lines away for a second. We're going to simplify it and bring it back and do just the stars of the horse and get rid of the rest here. So what you have to remember is there's no up or down in space. So things can fly sideways or upside down or backwards, and the horse is flying upside down. Put it on the drawings, it might be a little easier to visualize. It's kind of the bust of the horse. We've got the neck here with the head here. The square is the horse's body with the back, and these are the two front legs coming out here. So that's Pegasus, the flying horse. And the horse is not alone. Its foal is right beside it, right up here. And this is Equus, the little horse, or I like to call it the horse's colt or foal. It's just a little head of the horse, and that's all there is to that constellation. It is considered a separate constellation. We can put the boundaries up so you can see, a very small one. Go to the end of the horse's head. That's a star named Enif. I always remember that because it reminds me of sniffing. Enif, like you've gone far, Enif. That's the end of the horse, and maybe he's niffing the little horse here. Use what imagination you can to try to remember these things and see these things. There is another globular cluster right off the end of Enif, right about in here somewhere. Let's see if we can find it. Let's zoom in on this part. And it's going to be right up in here. Hold on one second. Let's see if I can get it. Yeah, it's right here, I believe. Yeah, there it is. It's always kind of a tricky one to find. It's tricky to find outside too. This one is called M15. It's not animal related other than it's right by the nose of the horse. But you can see an example of a globular cluster like the jellyfish cluster. And you see, it kind of looks like the jellyfish cluster, doesn't it? If you think the other one looked like one, you might think this one looks like one too. It's not called that. It doesn't have a common name that I know of other than its catalog number, which is M15. Now we had the NGCs, like we talked about earlier, the new general catalog. The M catalogs M stands for Messier. And that's named after Charles Messier, who was a comet hunter in the 1700s. And he really didn't care about these objects. He was hunting for comets, and comets, when they're far away and before they get up close with big long tails and things, they just look like fuzzy patches in the sky, but they slowly move through the stars. And in those early telescopes 250 years ago, these just look like fuzzy patches too, like they might be comets. And so he made a list of 110 objects that could be confused with comets. So he could catalog them, know where they are. So if he came across them, he wouldn't mistakenly think it was actually a comet. This was the 15th object he labeled in the sky. And it's right off the nose of Pegasus, the flying horse, right there. Now, I want to take you to what will be probably our most difficult constellation to visualize. So just to review here a little bit, we've got Pegasus and Equus, the little horse. And Equus is right off Delphinus, the dolphin. And remember, behind the dolphin, we have the eagle. And above them both, we have Cygnus, the swan, flying. And flying between them is Sagitta, the arrow. So we got all kinds of interesting things going on. We've got our music soundtrack. Everyone needs that. So there's the Lyra, the harp. Behind it, crawling over here, we find the lizard, Lacerta the lizard, and the queen Cassiopeia, where we found that ET cluster. Well, right behind Cassiopeia, there's a part of the sky with no bright stars at all. It's right up in here, and it's the giraffe, Camelopardalis. And so look at these stars and see if you can envision a giraffe here. Now, let me show you how they do it. We're going to get rid of those and just see if we can do the giraffe. Well, hold on. Right, let's try that. No, I get the wrong one. So let's shut that one off. I think it's probably more over here. See, even I have a hard time. There's the giraffe. Doesn't that look like a giraffe? Not. Camelopardalis was supposed to be the giraffe, and you'll see it if they draw it with a fancy picture. It would probably look something like this. The body of the giraffe with the long neck. Well, I know that's pushing your imagination. It pushes mine, that's for sure. It's not a constellation I spend much time. I'd never show it to kids. They love the name Camelopardalis. That's a cool name. Um, but there is one thing interesting to see here. Right underneath this body of the giraffe, they don't draw the legs for some reason, but right about in here, let's get rid of the picture. We find another planetary nebula, like the first one we saw, the Owl Nebula, where stars are dying. Now, we found nebulas. The red nebulas are places where stars are being born, and the planetary nebulas are where medium-sized stars like our sun die. This one is right in this region here. Let's see if we can find it. It's not very bright. It's very faint, and I'm not seeing it yet. Where did it go to? It should be right in here. Let's zoom in a little further. Wow, I see it. It's right here, kind of where that's marked by that star. So if we zoom in and get rid of our stars, we can see it better. You'll see, nope, I'm sorry, that's a cluster. See, even I had struggled with these things once in a while. So let's see if we can find, I found it just before here. This is one that I'd struggle with this with a telescope outside too. So we're going to find it with the old find tool right here. And this one is right there. Here it is. And when you get up close and magnify, and you'll definitely need a telescope to see this one. This one is called the Camel's Eye Nebula. Well, it's appropriate. It's in the constellation of Camelopardalis, which is the giraffe, but doesn't it sound like a camel too? It's also known as the Blue Oyster Nebula. Well, when I was a teenager, we listened to Blue Oyster Cult, a rock band that played heavy metal music, and we thought they were awesome. They should have had this nebula on one of their album covers. So this again is a dead star that was like our sun. It's about 5,000 light years away. And I couldn't find exactly how long ago this one exploded or died and burped its outer layers out, but it's the same sort of thing. And it's kind of a beautiful one to look at. Now, remember, if you do look at this, you're not going to see the blue color. It's going to look white. If you take a photograph, that blue color will show through, but to your eyes, it's pretty much going to look white to your eyes, but you might see some of that structure. So that's something to hunt for. And if you, that's probably the most challenging object to find. You saw I struggled to find it, and I just found it before we started to make sure I could find it again. And part of that is because it's in a constellation called Camelopardalis, which is made of all the stars inside that weird shaped polygon. And that's supposed to look like a giraffe somehow. Beats me. Well, those are our constellations devoted to animals today, but there are one or two more things I'd like to finish up with here real quick. I know we're pretty much at the end of our time, but there's one planet that you can see tonight, and it's going to be over in the southeastern sky. So we're swinging all the way around, and we have to stay up a little bit later. I've kept the sky kind of frozen at 9:15, so let's just go a little bit later, and you're going to see a bright star coming up, maybe around 9:30, quarter to 10. This one right here. Let's let it get a little higher in the sky. If you're out with a telescope, you want to let it get a little higher in the sky, because when you look at things down low, you're looking through a lot more air than when it's higher in the sky. If you look straight up, you're looking through about 50 miles of fairly dense air. When you look at something down low like that, you're looking through over 200 miles of dense air, just because the angle we're cutting through the air. So let's get a little higher in the sky, and we're going to keep you up to 11:30, get enough height so we can get a good look at it. And what we're looking at here is the planet Saturn. So if you zoom in on it and look at it, and you'll need a telescope to see the rings. If you look at it with binoculars, you might get a sense it's oval shaped because of those rings, but you won't distinctly see the rings. You do need a telescope to see it. Saturn is the second largest planet. The planet itself is 700 times larger than the Earth by volume. So it's very big. It has no ground. You can't land on it and get out and walk around. No one's going to plant a flag like Neil Armstrong on the moon. It's all clouds and gases and liquids inside, and the wind can blow through those clouds at hundreds of miles per hour. The rings are made of ice, mostly water ice. And from the inside edge to the outside edge, that distance right there is about 30,000 miles. So they're really wide. But thickness-wise, from top to bottom, they're only about 80 yards thick on average. 80 yards. Think about that. That's less than the length of a football field or a soccer field. Now, the rings were, as we go around the sun and it goes around the sun, we periodically pass the ring planes. So we've been looking at it from the top side, and then when we pass it, we start looking at it from the bottom side. And we're getting close to that point. We're going to be looking at the rings exactly edge on in March next year. And in mid-March, when we're exactly edge on, you're not going to see the rings at all. If you look at Saturn, you're just going to see a planet with no rings. The rings are there, but remember, they're only 80 yards thick, and you're looking edge on, and this planet is 1 billion miles away. Remember, 1 billion is a much bigger number than 1 million. So at that distance, you won't see the rings. And then by next summer, it'll be tilted enough so the rings will start to reappear, similar to what we're seeing here this summer. So we're about to lose them for a few months from our visual ability to see them. So that's kind of exciting. It happens about once every 15 years. These dots around our moons. And when you look at Saturn with a telescope, you can see many of those moons, though they will not look this big. They look almost as big as Saturn, don't they? That's a function of the program I'm using, so you make sure you see them. They're going to look like pinpoints, like stars. And this is the pattern they'd be in tonight at 11:30. If you went outside and looked at Saturn tonight, you'd see these moons all here. So that's the one planet you can see tonight, and it's definitely a planet you want to check out because it's pretty spectacular. Check those rings out this year, because next spring, when Saturn appears in the sky, those rings are not going to be visible. Well, I hope you've enjoyed the tour. We've kind of used up our time here, and it's kind of fun to try to find all these objects that were animal themed, and I think we found a pretty good complement of them. I can't think of any that I missed that are visible in the sky this time of the year. In the winter sky, you can also see the beehive, and there's a couple others probably too. I'm just blanking out on them right now, but it's fun to look and see what you can find. There are constellations in the winter, like the two dogs, and Leo the lion comes up in the springtime, so there are a lot more animal constellations in the sky. So I hope you get outside some night and see if you can find some of these animal constellations and celebrate what's in the sky, and keep an eye on Corona Borealis, the Northern Crown, and look for that blaze star that might appear anytime soon, because you never know when it's going to blaze up. It should happen within the next couple months.